Welcome back. Today we'll discuss the design of multiplexes. By the end of this video lecture, I hope that you will be able to sketch the logic circuit of multiplexer. This particular video is the first part in the designing of multiplexers. As you all know that multiplexer is one of the combinational circuits which has two n input lines and a single output line. Let us suppose we do have number of inputs and we need to select only one among them. And among all these inputs, we need to select only one among them. Then we go for a mux or multiplexer. Multiplexer in short is called as a mux. So it is just like a multi-input and a single output device. So whatever the binary information which you receive from these input lines, it is directed to the output line. So a digital multiplexer is one which reads binary input from any of these input lines and sends it to your output line. And based upon the values of selection lines, one of these data inputs will be connected to the output. So how do you select among these things? We will be having selection lines. So based upon the selection lines, here you will be having selection lines. So based upon the selection lines, you are supposed to select any one among these are the input lines. And this is your output. So based upon the selection lines, one of the input lines is selected as the output line. So unlike an encoder and decoder, which you have seen in your previous classes, an encoder and decoder, they will be having n selection lines and 2n input lines. Right? Here there is a total of 2n possible combinations of inputs. A multiplexer is also treated as mux. Now I'll show you how I'll start with the basic 2x1 multiplexer where you do have two inputs and one output. So if you do have two inputs and one output, which I'll show you. So this is the block diagram of a 2x1 multiplexer. Now this is an enable pin, you ignore that one, which is just used to turn on this device. So enabling pin. So this is your 2x1 multiplexer where you do have two inputs. Any one of these two inputs can be chosen to as the output. So which one is to be chosen? That selection is done by this selection pin. So if I take selection pin, let us suppose if it is also a digital one. So maximum options for this one are 0, 1. So if it is 0, I'll select A0. If it is 1, I'll select A1. So if it is 0, I'll go with A0. If it is 1, I'll go with A1. I do have two options. So based upon that, I'll be selecting the input lines. So in a 2x1 multiplexer, if you carefully see, there are two inputs A0 and A1, one selection line which I will call it as S0, and there is one output line 1. Okay, so based upon this output of the select line, one of these input lines will be selected as output. So if I draw the truth table of this one, so let us suppose what is S0 and what will be the output. If S0 is 0, then I will select A0 as output, and if S0 is 1, I will take it as A1. So this is the truth table. So my selection is being done based upon the select switch. This is my truth table. So if I take this one as S0 and if I take this one as S0 bar, then negation is represented as S0 bar, right? So what is my output Y? How to represent it? This is S0 bar A0. The other option which I do have is S0 A. Right. So this is my selection. Now, how to represent it in a logical form or in using gates? Now let us suppose how many options I do have. I have options of One is A1, the other one is A0, the other one is S0, right? So the first case is S0 A1. So S0 A1 both are multiplied, so I'll be using a AND gate. The other one is S0 dash A0. So A0 and this is to be negated, right? Both again, this is AND gate. And between these two, this is S0 bar A0 and this is S0 A1. Both are to be summed. So if I have to sum these things, what I should do? I should do an OR gate, right? So this is my Y. And this is the realization of this particular 2 by 1 multiplexer in the form of logical gates. So this is the block diagram, this is the truth table, and this is the function, and this is the realization using gates. Understood? See, this is the logical expression which I have told you. Y is equal to, see, this is your truth table, right? Yeah, this is the truth table. If S0 is equal to 1, I'll be going with A0. If S0 is equal to 1, I'll be going with A0. So this is the logical expression, and as I have shown you, this is my representation using logical gates. Now let's see 4 by 1 multiplier, 4 by 1 multiplexer. In 4 by 1 multiplexer, how many inputs you will be having? You will be having 4 inputs, right? A0, A1, A2 and A3, right? This is 4 by 1 marks. Among these, you are supposed to select one wire. So how many options do you require? So it is decided on 2 to the power of n, where 2 power n is number of input lines and n is the select lines. So now 2 power n, this is 4, right? So 4 is equal to 2 square, right? So 2 will be the select lines which you do require. In the earlier case it was 2, 2 is equal to 2 power 1. So 1 will be the select line. If you do have 7 inputs, the next higher number is 8, right? So I'll choose 8, I'll take it as 2 power 3. So 3 will be the number of select lines. If I do have 14 inputs, the next multiple of 2 is 16, right? So 16 means 2 power 4, so 4 select lines will be there. So in my case, now this is 4 by 1 multiplexer. So 4 is equal to 2 square. So I'll be having 2 selection lines. So now 2 selection lines I do have. One is S0, the other one is S. When I do have 2 selections, now what are my options now? S0, S1. Either they can be 0, 0, or they can be 0, 1, or they can be 1, 0, or 1, 1. If it is 0, 0, I'll go with A0. This is my output. And if it is 0, 1, I'll go with A1. If it is 1, 0, I'll go with A2. And if it is 1, 1, I'll go with A3. Right? So this is the representation. So in this case, how will you write this expression now? See, what is my output, final output? Y is equal to first case plus second case plus third case plus fourth case. What is first case? S0 is negative. So S0 dash, S1 dash, A0. Second case is S0 dash, S1, A1. Third case is S0 is 1. So I will write S0. Whereas S1 is 0. So I will take it as dash, A2. This is S0, S1, A3. This is the representation. And this is my truth table, 4 by 1 multiplex, and this is my expression, logical expression. Now, if I want to realize it using logic gates, so how many inputs I do have? Literally, I do have 4 inputs and 2 select gates, right? So what I'm supposed to do? 1, 2, 3, 4, and I do have 2 separate things. One is S0, the other one is S1, right? This is A0, A1, A2, and A3. So how will I do that? The first one is S0 dash, S1 dash, A0. So for each of these things, what I will do is, this is S0 dash. right? And this is S1 dash. So this is S0 dash and this is S1 dash. So the first one is S0, S1 dash, A0. So A0, S1 dash, and so these three are AND gate. The second one is S0 dash must be there, S1 must be there. So S0 dash, A1, S0 dash, and the other one is S1. So similarly these things. So all these things again, what they should be done? They should be subjected to an OR gate. So this is my output. So this is the way how you will be realizing through gates. Now, see this is the representation 4 by 1 multiplexer. So this is your block diagram. See how many inputs are there? There are 4 inputs as already mentioned. There are 2 select lines, one is S0 and the other one is S1, and 1 output. See 4 inputs A0 to A3, 2 selection lines S0 and S1, 1 output. So based upon the combination of inputs that are present on the selection lines, what can be the options? I told you no, 0, 0, 0, 1, 1, 0, 1, 1. So based upon the selection, any one of these input lines will be connected to the output. Now this is the truth table which you have already seen. If it is 0, 0, it is A0. If it is 0, 1, A1. 1, 0, A2. 1, 1, it is A3. So this is the logical expression which we have already written. Right? So this is the realization as I already told you. A3, A2, A1, A0, and these are S1 and S0. And these are the NAND things. This is S1 dash and this is S0 dash. So combination of these things and using an OR gate, they are getting the final outputs. Understand? Now similarly, an 8 by 1 multiplexer. As already told, in the 8 by 1 multiplexer, how many inputs will be there? There will be 8 inputs, right? If you take it as a multiple of 2, you can add it as 2 to the power of 3, right? So 3 select lines will be required. So which means that your multiplexer will be just like this one. 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Yeah, I think one more is missing, right? A0 to A1, A2, A3, A4, A5, A6, and A7. So here you will be having how many? S0, S1, and S2. 3 lines you do require. So based upon these 3 lines, now S0, S1, and S2. What can be the combinations of these things? It can be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0. Yeah. It can be 1, 0, 1, it can be 1, 1, 0, and 1, 1, 1. See 1, 2, 3, 4, 5, 6, 7, 8. First case A0, second case A1, next A2, next A3, next A4, A5, A6, and lastly A7. This is the 7. So 8 inputs are there. So how will you realize this one? What is the logical expression of this one? For the first thing, if you carefully write, it is S0 dash, S1 dash, S2 dash, A0. Second one, S0, S1 both are negative, so S0 dash, S1 dash both are negative. S2 is positive, so S2, A0. Sorry, it is A1, right? So it is A1. Similarly, in this case, so like this, all inputs will be added. And once you do have this, you are supposed to realize it with the help of gates. So you will be having 8 inputs 1, 2, 3, 4, 5, 6, 7, 8 A0 to A8, and you will be having S0, S1, and S2. And you can for your sake, you should also draw S0 dash, this is S1 dash, this is S2 dash, right? So you join these things and you will be, so in the first case S0 dash, S1 dash, S2 dash, right? So which means that this and A0 should be joined. And get. Next similarly for A1, next similarly for A2, and all these things are to be joined through NAND OR gates, right? So this is the representation of 8 by 1 mux, right? See here, in this 8 by 1 mux, how many select lines are there? 3 select lines in 8 inputs are present. And see, this is your logical expression, and this is your truth table, and see, this is your diagram. Realization using logic gates. How many inputs you do have? A0 to A7. 8 inputs you do have. See, S0, S1, and S2. What they have done? They have obtained these things also. So, 8 AND gates and 1 OR gate. Right? This is the way how you will be realizing. Okay. Now, if you go with a 16 by 1 multiplex, if you go with a 16 by 1 max, so how many inputs will be there? 16 inputs will be there, which is equivalent to 2 power 4. So how many lines will be there? 4 select lines will be there, right? So 16 AND gates will be there and 1 OR gate will be there. 16 by 1 mux. So this is the way how mux are realized using logic gates. Okay, and in the next class we will see how instead of using directly, we will try to realize higher order mux using lower order mux. Okay, that we will see in the next class. Okay, so I hope that you have understood that a multiplexer is a combinational circuit which has two AND input lines and a single output line. Simply, it is just called as an multi-input single output combination circuits. Okay, so I hope that I'll be asking these problems in the examination. I hope that you will be sketching these logic circuits of this higher order multiplexers also. Okay, thank you. We'll discuss more problems in the class. Okay.